In a previous video, we talked about the nuclear model of the atom, but we didn't always understand this much about the atom. In fact, I did say that the ancient Greeks thought that the atoms were the smallest possible thing. In fact, it was only just about 100 years ago that we still believed that atoms looked quite different. We used to think that they looked a bit more like this. This is called the plum pudding model of the atom. So you can see that the atom is depicted as being this big ball of diffuse positive charge with these little negative electrons dotted throughout it. So how did we figure out that this wasn't quite right, and how did we arrive at the idea of the nuclear model? Well, it all came down to one experiment called the alpha scattering experiment, carried out by Ernest Rutherford and his colleagues in 1909. But it actually took him a couple of years to figure out what exactly they were seeing in this experiment. So let's talk through what they saw. Well, the setup is fairly simple. They fired a beam of alpha particles at a thin sheet of gold foil. So the sheet of gold foil was only a few atoms thick, really, really thin, and alpha particles are tiny, dense, positive particles. Now, because they thought that the plum pudding model was correct, they thought these atoms in the gold leaf were big, diffuse, not very dense, positive sort of mush. They thought that the alpha particles, being as dense and solid as they were, would sort of just fly straight through these atoms. And most of them did, but some of the alpha particles were sort of deflected through an angle like this. They kind of bounced off at a weird angle, and some of them bounced straight back at where they'd fired the alpha particles from. And this was really unexpected. In fact, Rutherford is apparently quoted as saying, "It's like shooting a rocket at tissue paper and having the rocket bounce back off the tissue paper." So really crazy sort of result, according to what they thought at the time. So what this means is that most of the mass in the atom must be concentrated in a tiny, dense ball, because that would make sense as to why most of the alpha particles flew straight through. They were missing this ball, but the ones that were deflected or reflected must have hit this really, really dense thing. And that really, really dense thing must also be positively charged, because the alpha particles are positive. So if they're going to reflect off it, has to be the same charge, because similar charges repel. So that led to them concluding that most of the mass in the atom must be concentrated in this tiny little center, the nucleus. The nucleus has to be positive, which means the electrons are probably floating around outside it. And if most of the mass is concentrated here, then most of the atom must be empty space, allowing the alpha particles to flow straight through. And we now think that, well, yes, the atom actually is mostly empty space. In fact, the size of the nucleus is 100,000 times smaller than the atom itself. Pretty crazy. So there it is, one of the most important experiments of its time, the alpha scattering experiment, and how we used it to better understand the nature of atoms.